Let's learn Euclid's division lemma, theorem 1.1. This is in chapter 1, real numbers. So before this, you can see the previous videos about Euclid folk puzzles to follow this and examples also, so that this will be easy for you. So let's start. We are given positive integers a and b. Then there exists a unique integers q and r, where q and r are quotients and remainder. If this equation is there, then it has to satisfy the below equation. Is a equal to bq plus r, where r should be between 0 and b. So this is only division lemma. In previous videos, we have checked many examples for this to understand. If you are not aware, you can check that. So now we'll see Euclid's division algorithm is a technique. So for what is this technique used? This technique is used to compute. To compute what? It is used to compute highest common factors or greatest common divisors. You want to know in real life where this is used? You can just check the link in the below description to find where HCF is used in real life, so that it will be more interesting for you to know and learn. So how Euclid division algorithm works is this. We already saw that we are going to just find out the HCF, highest common divisor. We'll take this example and we'll start. So 455 and 42 are A and B. So in here we have to consider the highest number. The largest number is 455. So from the folk puzzle, equation is A equal to B into Q plus R, where A and B are positive integers. Here it is 455 and 42. Q is the quotient and R will get the remainder. So now we'll start. You can take A. A is 455 and B is 42. 42 into 10 if you do, we will get 420. But that is not equal to 455. So adding 35 makes it. So now with this, we'll derive the values for this. A is equal to 455, B is 42, Q is 10 and R is 35. So now we have to continue this algorithm until we get R equal to 0. So now R is not 0. So we have to continue with finding the HCF of B and R. So B is 42, R is 35. So now we will find the HCF of 42 and 35 using the same method. Same thing, 42. So 42, if you take and 35, 35 into 1 is 42. So you have to plus 7. So here again we'll write A equal to 42, B is 35, Q is 1 and R is equal to 7. 7 is not 0, so you have to proceed it again with 35 and 7. HCF of B and R, 35 and 7. So now we are again proceeding, 35 equal to 7 5 are 35. So I think here it can stop, plus 0. So we got the remainder as 0. So HCF of this should be 455, 42 is equal to 7. So now we'll see the algorithm steps. How whatever we did in the example, we'll see in the algorithm step. So what is the step 1? Apply Euclid's division lemma to A and B. Instead of A and B, here in the theorem they have given C and D, that's all. To C and D. So we find the whole numbers Q and R such that C equal to DQ plus R, where R is between 0 and D. Exactly the same example whatever we've seen. We have seen with A and B, this is replaced by C and D. This is the first step. So next we know already what we have to do. We have to check the R and proceed. So if R equal to 0, then D is the HCF of C. If R is not equal to 0, then you have to apply the division lemma again to D and R. So this D and R. So continue the process till the remainder is 0. The division at this stage will be required. Divisor at this stage will be the required HCF. So each time, first time when you apply HCF equal to CD, and then HCF of D and R both will be equal. Now we'll see the flow chart for the Euclid algorithm. Let's start. So same algorithm giving in the diagrammatic form. That's all. That is the flowchart. So you are getting the number A and B. Then what we are doing? We are finding if A is greater than B. If A is greater than B, yes. Then what we C is greater than D. Then we have to divide C by D. That will give the quotients, and we are finding the remainder. If C is not greater, then we have to divide D by C. Then we have to do D by C. So now we got both these things. Now we need to find out whether we have to proceed or not. That we can proceed depending on the value of R. So now check the value of R in both cases. If R equal to 0. If R equal to 0, yes, then we have found out the LCM. Sorry, HCF. HCF is D. If not, then we have to again reiterate it with C equal to D and D equal to R. We go back here. So this is how you can, this is the example diagram flowchart which you can try to understand it. Thank you.